Space weather. Do you want to learn more about this? Or this? Or even this? And stay tuned, because all of these amazing happenings are space weather! What is space weather, you ask? It is defined by the National Aeronautics and Space Association, or NASA, as conditions on the Sun and in the solar wind, magnetosphere, ionosphere, and thermosphere that can influence the performance and reliability of spaceborne and ground-based technological systems that can endanger human life or health. Whoa. That's a pretty complex definition. In brief, space weather is the condition of the sun and the solar wind, as well as how it affects the Earth and its atmosphere. We will be referring to 6 types of space weather: solar wind, solar storms, sunspots, solar flares, coronal mass ejections, or CMEs, and the aurora borealis. Solar winds come from the sun's corona, particularly when the temperature of the sun's corona is so high that the sun's gravity cannot hold on to it. Solar wind streams off of the sun at about 1 million miles per hour. The corona is an aura of plasma that surrounds the sun and other celestial bodies. The sun's corona extends millions of kilometers into space and is most easily seen during a total solar eclipse, but it is also observable with a coronagraph. Sunspot, coronal mass ejections, solar flares, solar storms, and the aurora borealis are very closely linked. The combination of the scalding 15 million degrees Celsius and high pressure in the sun's core cause hydrogen atoms to fuse together and form helium atoms. This creates the sun's energy. This energy radiates out into the radiative zone, wherein it stays for approximately 170,000 years before going into the convective zone. In the convective zone, it is only 2 million degrees Celsius. Here, the plasma circulates in whirlpools called convection cells.
BTW, plasma is an ionized gas consisting of positive ions and free electrons in proportions resulting in more or less no overall electric charge, typically at low pressures, as in the upper atmosphere and in fluorescent lamps, or at very high temperatures, as in stars and nuclear fusion reactors.
These convection cells have magnetic fields, and when the magnetic field is strong, it may go through the surface. This quick eruption is called a solar flare. When the magnetic field breaks through the surface, the convection cells in that area cool, creating what are called sunspots. The magnetic field can twist and stretch until it snaps, dramatically hurling several billion tons of plasma into space. Coronal mass ejections are this flinging of matter. These are often associated with solar flares, but sometimes coronal mass ejections occur and no solar flare is observed. Now, there is a mass of plasma, also known as a solar storm, traveling through space at high speeds. They generally travel at 1 to 2 million miles per hour. Thus, it usually takes 2 to 4 days for the solar storm to reach Earth, but a solar storm released on July 23, 2012 took 18 hours to travel the distance to Earth. That's about 5 million miles per hour. Luckily, it did not hit the Earth. However, when the solar storms do hit the Earth, it is prepared. Earth has a magnetic field of its own that diverts the storm, funneling plasma into the north and south poles. This is the daylight aurora. When it reaches the other side of the Earth, it meets the magnetic field on that side. Plasma is once again funneled into the north and south poles, causing the nighttime aurora. Solar storms can create beautiful scenes, as evidenced by the aurora borealis, but they do have some negative effects on our lives. For one thing, they interfere with some radio communications. They also give Earth-orbiting satellites shorter lifetimes in orbit. They can also affect the accuracy of Global Positioning System, or GPS, measurements. Keep in mind that solar storms are extremely dangerous to living organisms, and our shield is the Earth's atmosphere.
Thanks, atmosphere!
Coronal mass ejections disturb the Earth's magnetosphere, causing a geomagnetic storm. This can cause damage to satellites and may even cause blackouts over a large amount of area. Quebec experienced such a blackout on March 13th, 1989. It lasted 9 hours.
Next time you hear a meteorologist or a weather reporter talk about the weather, remember that there is more to weather than cloudy or sunny. There is also the beautiful space weather!
Space weather, space weather, space weather, space weather, weather.